Welcome to another Onshape tutorial. In today's video, we're going to go through the Coil or Helix tool. We can use this tool to create things that are like a spring. There is a lot of new vocabulary and terminology that goes along with this tool. We're going to kind of describe that as we go. So the first shape I'd like to make with you is this spring that you see here. And as I take a look at it, we're going to go ahead and define a couple of things. One of them has to do with the actual body itself, and it looks like it's just a circle that goes around some type of axis, and that's true. So the first thing we want is a profile that's just a circle. I can see that this spring is also just kind of a cylindrical shape, or wraps around some kind of cylinder, and that's going to be important as well. The next thing to identify is that there's some kind of spacing that's actually in between each one, and we'll get to that too. Well, why don't we just go ahead and hop into Onshape and see if we can't get it started. As it is with many of the tools we've been using, there's a lot of different ways that each one can be used. It is kind of important that we go through a couple different ones because Coil gets used in several different ways for several different reasons. So for this spring, I'm actually going to make this one 3 times. But I would encourage you to go ahead and do it 3 times as well, 3 different times that is, so that you can go ahead and experience each way that you could use this tool. So the first thing I'm going to do is go ahead and start with a sketch, and I'm going to select the top plane so that my spring can go up and down. I'm actually going to create a cylinder. And that cylinder is what I'm going to wrap my coil or helix around. So I'll go ahead and finish sketch, and I'm going to go ahead and extrude that cylinder. Now, just by drawing that, I've already defined 2 things about my spring. I've already decided what diameter the main body is going to be and the height of it. So this one block, or this core that's here, has already defined those things for me. The next thing to do is to actually select the Helix tool. For this example, we're going to use it mostly with its defaults. And the thing that it wants us to select is a conical or cylindrical face. Conical means cone shape, and cylinder is a cylinder. So I have a cylinder, and I'm just going to pick this outside body. As soon as I do that, you can see these black stripes now going up the cylinder. Well, that's my coil, that's my helix, or that's the path that my little circle is going to follow. I also have the opportunity to change it from clockwise to counterclockwise. I've got the opportunity to go ahead and change the number of revolutions, and I can also change its start angle. The start angle has to do with whether it's going to start on the right or the left or anywhere around there. So 0 right now is starting over here, which you kind of can't see. It's wrapping around the back, starting over here on my right-hand side. If I go ahead and put something like 180, then that's changed it, and now it's starting over here on my left-hand side. Majority of the time, I'm going to put my profile on the front view, and since I'm going to do that, those are usually the 2 start angles that I work with, 0 and 180. Alright, so what do I do from here? Well, I'm going to go ahead and accept the helix. So that's going ahead and define my actual path. And now all I need is that profile. So I'm going to create my sketch on the front view, and over here on the right hand side, I have the point where that's actually starting. So I'm going to lock my circle onto that. And that's really it. I'll go ahead and finish sketch, and now I'm going to go ahead and sweep that. I'm going to use the sweep tool to take that profile and drag it along that path all the way up to the top. And that's really it. The problem is, unfortunately, my cylinder and my coil just joined. They're now one solid piece. That's not what the cylinder was there for. The cylinder was just there to define the path. So I'm going to go back into the sweep, and instead of saying add, I'll say new. Once I do this, this is now 2 completely different parts or features. I can come down here to the bottom, and I can actually just turn part 1 off. And as I do that, I'm left with just the coil by itself. Before we leave here, though, there's a couple things that I want to really look at. So the first thing I really want you to notice is that blue cylinder is actually part inside my coil. That's unfortunately because that's the way I drew my coil. When I drew that circle, I locked it onto that bottom corner, so now my coil is kind of half on, half off that blue cylinder. If I actually wanted that blue cylinder to be the core, or the total inside, then my circle would need to be off to the side a little bit. Let me show you. So now that blue cylinder truly is a core. It is now the inside diameter of the spring that I've got. So if you're using the defaults that are currently there, you have to go ahead and understand a couple things about it. Number 2 is the height. When I went ahead and coiled this, you can see that I actually have part of my circle living below the coil as well as above the coil. And even if I had cut my circle in half, I still would have had that other half of it go past the object. So that's the other thing I want you to truly notice is when you use this cylinder to define the height, you'll always get the height of whatever object you start with above the height that you've got. We can change that and we can control that, but that's just using the defaults as is. So that's the first 2 things I really want you to understand is anything that's inside the blue will be inside the blue and may not be the dimensions that you want. As well as when you go ahead and coil it around, it will always go ahead and coil one additional shape on top of whatever you've got. Okay, let's go ahead and do strategy number 2. I'm going to start it off the same way. I'm going to do a sketch on the top. Go ahead and draw my circle, and that's going to define my core's diameter. I'm going to go ahead and extrude that and bring it up. But if you remember the last one, I really didn't need all of that. I don't need it as a solid anyways. All I need is the diameter and the height. Those are the 2 things that my coil went off of. So we're going to do the extrusion just a little bit different. When we go to extrude this time, instead of extruding a solid, we're just going to extrude a surface. When we do that, I can go ahead and pick my cylinder, decide whatever height it's going to be, and say OK to that. And now I don't have a solid. There is no real cylinder per se there. It's just a thin wall that really doesn't have any thickness to it at all. I can now go ahead and do everything the same as I did last time. I can say Helix, pick the body, say however many revolutions I would like, select OK to that, put on my profile, sweep that along the path, and say OK. And now that that's done, if I come down here to the bottom, I have 2 of them. I have one that says surface and one that says curves. The one that says curves is actually that helix itself. So if I turn that off, it's gone, and it was inside my part, so you couldn't see it anyways. The other one I want to turn off is surfaces. As soon as I do that, everything is gone and everything is good. So I really didn't need an entire cylinder there to begin with, not as a solid anyways, and not for this tool. So that's really the second way, is if I don't have a core that's going to stay, or some type of main body that this is wrapping around, and it's going to get turned off anyways, then it might as well just be a surface. And now to use this tool the third way, we're going to have a little bit more information. Let me go ahead and kind of start it off like number 2. Okay, so let's go ahead and open back up the Helix tool. For all the examples I've shown you so far, we've used turns as the default type. If I open this up, you can see that there are some others. The first 2 don't need a height because my cylinder has already defined my height. So I can use turns or pitch for either one. Turns is the number of revolutions that actually go around the cylinder. And yes, you can have that as a decimal. The pitch is defined when talking about springs or threads as the start of one measured to the start of the next one. So if we're talking about a thread, we could go from the start of one thread to the start of another thread, or the middle of the thread to the middle of the thread, as long as you're matching up 2 corresponding points. So this time if I say pitch, the number that I'm putting in here is actually the distance from one to the next. So if I go ahead and select my cylinder, the number of revolutions or turns that go around it is decided by the spacing that I've got. If I decrease the pitch, then it'll increase the number of turns. So right now I have the option to do turns or pitch. But I also have these other 3. I have heights and turns, heights and pitch, turns and pitch. And I'm going to select this first one, heights and turns. The first thing you're going to notice is that that opportunity to select conical and cylindrical has disappeared. It now just wants a circular edge. So it just wants this bottom face. And as soon as I do, everything is measured from there. So I don't need a cylinder at all. All I needed was a circle if I knew any of these. If I knew the height and the number of turns, the height and the pitch, or the turns and pitch, then all I really need is a circle. So if I started out with just a circle, and I said I knew the height and turns, if I select my circle and say that I'm running something like a 4-inch overall height with 4 revolutions or 6 revolutions, that's changing the pitch, it'll do the exact same thing for me. So I really didn't need that for this example at all. So if I'm trying to create just a spring by itself, all I needed was the profile and the path, and that's it. So that's 3 completely different ways to get the exact same results. I could either start with a core as a solid and then turn that off. I could start with a core as a surface and turn it off. But if I know enough information, I could just start out with a circle and allow the software to do everything else for me. All right, well, let's see if we can't hop into another example. All right, for this example, I'd like to try to make this water slide or playground slide. First thing we're going to do is identify the actual profile, and it looks like I have a rectangle and a rectangle that make the walls and 2 concentric arcs that are tangent to those rectangles to try to make this inside curve. I can also see that I have a cylindrical area in the middle that doesn't get to stay, so I've got to decide what strategy I'm going to use to try to make this. Let's see if I can't knock it out real quick. For this example, I'm actually going to do that cylinder as a revolve, just to show you another way to do it. So I'm going to go ahead and draw the rectangle in here, and that's going to define my height and my diameter for the core itself. I'll go ahead and draw the slides walls, and I'll do 2 3-point arcs that are tangent to those. Okay, so unlike the spring, I've drawn this completely on the outside. So the rectangle that I have here in the middle, once I revolve that to create a cylinder, it will be a true core. Now as far as its height, we're going to have to think about that a little bit. But let's go ahead and see if we can't move on to the next step. Okay, so there is my cylindrical core that's there as a surface. I'm going to go ahead and turn back on sketch 1, just so I can see it, even though I'm not really ready for it yet. I'll go ahead and go to my Helix, and I can really do any of these options since I'm not putting any specific dimensions on here or trying to get an exact slide. I'm just trying to get one that looks very similar to this one. Another thing that you may notice about this slide is it doesn't make 2 full revolutions. It only makes 1.5. So back in Onshape, I need to choose one of the options that allow me to control the turns. So let's just go ahead and go with turns, and I'll go ahead and select the body. So the turns or revolutions is only going to be 1.5. And it just happens to be that when that wraps around, it actually ends at where I drew the slide. If I had drawn the slide on the other side, that may have been one of those times where I wanted to change the start angle from 0 to 180, and then my slide would have started on this side. But it didn't. I got lucky, and it just happened to land where I drew it. And so far, that's it. So let's just go ahead and accept the helix, sweep, and I'm going to pick all 3 objects, pick my sweep path, and go ahead and pick the path. Now, just as we said earlier, even though I've gone ahead and designed this slide right at the top of my cylinder or my full height, it has gone ahead and traveled down an additional slide down across the bottom. If that's not what you want, you have 2 options. I could have either changed the height of the cylinder itself to match up what I wanted, or I would have had to gone into the helix and done some math to try to figure out how to get this to actually land where I wanted, to either decrease the pitch or height, either one. So just remember that with the Coil tool, if it ever produces results that's not exactly what you wanted, you need to know why it did those results, why it created what it wanted, and how you're going to fix that so that you can go ahead and turn that in or alter that to what you want. The next 2 examples are going to be very similar to each other. We're going to try to create some threads. Now, the first time we're going to do it, they're going to be on the outside or creating them as a solid. The second time, we're going to try to sweep them as a cut and actually remove them from it. Let's see if we can't try to create them. Okay, so to start this one off, we know we have a cylinder in the middle and the cylinder gets to stay. You've already seen that we've got 2 easy ways to make a cylinder. I can draw a circle and extrude it, or I can draw a rectangle and revolve it. Because I'm going to go ahead and put the profile on the edge of that, I think I'm going to go ahead and do it as a revolve just to maybe save myself a sketch. So that's the body of the bolt. And I know if I use the default helix that the 0 degrees is going to be where it starts. So down here at the bottom is where I'm going to draw my thread. For this example, we're going to draw an Acme thread. And there's a whole bunch of different thread styles out there. For ours, it's just going to kind of come in at an angle, straight up, and then back at an angle. And for our example, that's going to be good enough. If you want to go ahead and throw some dimensions on there to clean it up, that's completely up to you. So I'll go ahead and revolve the cylinder. I'll go ahead and throw a helix on there. And I'm going to go ahead for right now, and I'll increase the revolutions. I'm going to turn back on my original sketch, which held both the cylinder and the thread profile, and then I'll try to sweep it. And I can see right now that I either have way too many revolutions and the threads are running into each other, or my thread is too big. That's really the problem with trying to design and not have any dimensions. So I'm going to go back into my sketch and see if I can't make that thread a lot smaller. And now I probably need to go back in and increase the count. And again, that's really the problem with not actually starting out with any real dimensions. But because the software is parametric, all I should have to do is go back into the helix and change it, and it should update everything from there. There, that's starting to look better. And again, unfortunately, it really doesn't give me a good start transition where it turns into the thread or starts as a thread, and it does the same thing with not really stopping at the end of the cylinder. But we've already discussed that. So there's a lot of things you're going to have to do to try to get this to land right. And a lot of that can get solved by cutting the threads instead of creating the threads as a solid. Well, let's try to do that one. So I'm going to start off the exact same way with a rectangle. And this time when I make the thread, instead of starting the thread on the outside, my thread's going to be inverse. And be on the inside. Okay, so this time when we come to helix, I'm not going to leave it at just turns. I don't want the blue core here to actually define the height. Since it's going to be a cut, I actually want it to run right off of the part. So I'm going to go ahead and change it from turns to, how about height and pitch? So I'll do height and pitch. I'm going to go ahead and select my circular edge. It has actually gone down, so this black arrow will allow me to swap directions. I'm going to go ahead and say that I want a height of something like 3 inches, and I know that runs off of the part, and that's fine. I actually want it to run off the part. I may even want something a little bit bigger. But once I say pitch, pitch is going to get evenly distributed along whatever my height is. So if I say a pitch of something like 0.25, then it'll figure that out for me. And again, it's just going to run off and cut into air or cut into nothing. And that's perfect. That's going to give me a nice transition since I actually started below the part. And it's going to give me a nice exit on there up at the top to give me a nice transition out of the part. And remember, this time we're doing it as a remove. And it looks like I could go ahead and have a pitch that's a little bit tighter. So I'll go ahead and accept that. And because I have the height already defined, the height will always be the height. So I don't have to worry about that. I'm just going to go ahead and close the pitch. And that looks a little bit too small. There, that looks pretty good. So again, I have a much better transition here at the bottom where it starts out as nothing and folds into a thread. And then I've got the same thing up here at the top. Just so you get the idea of how the coil tool actually works, I'm going to run through the process of actually making a real life bolt. I'll be right back. Okay, so moving on to another example. This should actually be one of the easier ones that we have. The only reason I'm trying to show you this one is because it's a tapered coil, When would we ever see a tapered coil? Well, how about those spring door stops that you may see at the bottom of a door? Or how about those springs that are inside a remote control for the battery compartment? So if we interpret the part, we see that we still have a circle as a profile, but this time instead of having a cylinder, we've got a cone shape. Well, let's see if we can't do it. Okay, so that one wasn't so bad. Is it editable? Yeah, sure. So if I go back into the original sketch and I go ahead and edit up that truncated cone, or a cone that's missing its top, then it should go ahead and update everything for me. So there's your tapered coil. For this last example, I want you to try to take everything that you've learned and put it all together to try to make this pin spring. You have a tight coil or a tight helix, an open helix, and a tight helix again. You're probably going to have to put some work planes on it and quite a bit of thought. I'd like for you to pause the video and see if you can't figure it out. And if not, here in a second I'll go through it with you. Good luck. As I said, there's a lot of ways to do this pin spring, and this is just one of them. I'm going to go ahead and start a sketch on my top plane, and I'm going to put on the circle that's going to make the inside diameter. I'm just going to go ahead and put a 1-inch diameter on there. Because there is a lot going on here, I am going to go ahead and put on some real dimensions. I'm going to go ahead and do the rest of my layout line here, so I know that this coil is going to go up to another level where that's going to stop the tight coil. So I'm going to go ahead and do an offset work plane from the top, and I'm just going to pull it up 1 inch, and that's fine. I'm then going to go ahead and do another offset plane from plane 1, and I'm going to go up 2 inches. From that one, I'll go ahead and finish my last helix. Well, I need a circle on each of these other 2 planes. They need to be in line with the original one. So I'm going to go ahead and do a sketch on plane 1. Then I'm going to go ahead and project my circle from my top view up to plane 1. Then I'm going to go ahead and repeat that process for plane 2. Then I'll go ahead and establish all 4 of my helix. So I'll go ahead and do my first one. I'm going to do a helix. I'm going to change it from turns to height and pitch. I'll go ahead and select my circle, and 1 inch is going to be my height. My helical pitch, I think, is going to be 1/8 of an inch. And that should make 8 of those little circles. I'll then go ahead and do another helix with the exact same thing, height and pitch. This time I'm going to go up a height of 2 to reach my other plane, and I'm going to open up the helical pitch. So instead of being 1, I'll make it like 0.5, something like that. Something that you evenly get me to the next transition. So that is the important part. As my helixes are coming around, I need them to actually meet at the right place. And then I'm going to do one last one. And that's really it. So I now have a tight helix, an open helix, and another tight helix. I'll go ahead and create a sketch on my front plane. I've got a whole bunch of planes going on here, so it might be to your advantage to go ahead and start turning some off. That's the only plane that I really still need. So I'll do a sketch on my front plane. I'm going to put a small circle on there. Now it has to be fairly small. Some software doesn't like it at all when these coils overlap. It seems to be that Onshape is okay with it, but I need something smaller than 0.125. That's when they would run into each other. So I'm just going to go ahead and say 0.1. All right, let's see if we can't sweep it. If all of my dimensions are exactly correct, then I should be able to go ahead and sweep this in one shot. I can go ahead and pick the profile and pick my sweep path, and I should be able to get the tight loop, the open loop, and another tight loop. If it doesn't want to do it in one solid sweep, you can do it in 3 separate ones. So I can do a sweep, take my small circle, and finish the first path. I then don't have to create another circle. It's already there. So I could just go ahead and say sweep again, pick the circle and the path, and then just repeat that process on up the line. But if you pay close attention to your dimensions, then you probably can get this to work all in one shot, and that's pretty cool. Hope you can now start adding coil features to your designs.